I'm delighted to introduce Florian Alt for our next invited speaker. Florian Alt is a full professor of usable security and privacy at the Bundeswehr University in Munich, Germany. His research is at the crossroads of human-computer interaction and IT security. In particular, Florian is interested in how novel, secure user interfaces can be built that blend with the way in which we interact with computing devices. Specific research areas include, but not limited to, behavioral biometrics, social engineering, usable security in smart homes, and secure physiological user interfaces. Florian co-authored more than 200 publications, many in leading venues of his field, such as SEM SIGCHI, SEM WIST, and SUPS. Florian holds a diploma in media informatics from LMU Munich and a PhD in computer science from University of Stuttgart. Let's give him a big virtual hand and let's hear from Florian Alt.
Thank you very much, Ahmed. And thank you so much for this nice introduction. So this will be sort of quite a leap in terms of the topic I'll be talking on, but still I hope you'll enjoy this. So this is actually my first time in the Graphics Interface Conference, and I appreciate having been invited here. And so in my 20 minutes, I want to take you on a brief journey through the world of behavioral biometrics, a line of research that I'm working on with my group. And in particular, I want to talk about challenges and opportunities from an HCI perspective. So you already introduced me, so I think I can just keep that short. So I just wanted to say that, well, my background is in media informatics. I then basically left university for a while after graduating, working in industry, in particular for 1.5 years in the US, but then came back to do a PhD in various locations in Germany, and ultimately, as you said, graduating from the University of Stuttgart. And then I accepted a faculty position at LMU in human-computer interaction before 3 years ago. I decided to transfer to a research institute for cyber defense, where my work is now more at the intersection of IT security and HCI. And this sort of research area is commonly referred to as behavioral biometrics. All right, so my work has very long since been inspired by Mark Weiser and his vision of a world in which computers are ubiquitous. And so he was the one who, at the beginning of the 1990s, predicted that we would soon be living in a world that would be dominated by different types of output devices, which he referred to as taps, pads, and boards. And if you look back at that vision today, 30 years later, we see that this vision has, well, largely become true. So we have those devices. We call them a bit differently, but I think it's fair to say that they have become ubiquitous. But the interesting thing here is that this is not the end of the story. So because today we witness that, that there is more and more technologies that at least do have the potential to also become ubiquitous entering the market. And I just brought a few technologies here, many sort of intelligent devices, smart home devices, AR, VR, HMDs. And now taking the perspective of the security researcher here, what is quite striking is that the development of security mechanisms is not keeping up with that pace at which those technologies sort of emerge. And the reason for this is that we as designers, and I include myself here, are, I guess, quite good at adding exciting new features, at exploring new application areas. But then we rarely think about the fact that such technologies are often dealing with sensitive data that need to be protected. And often this need to protect data only becomes apparent as technology starts to, well, being used in daily life. And as a result, what you often see is that people try to fix security post hoc. And this in many cases leads to sort of, poor usability. And just to bring one example, thinking about TVs, so as they became connected to the internet, became smart TVs, well, the need for security mechanisms was not really anticipated or addressed. And so what happens today, if users want to authenticate with their favorite video streaming platform on their smart TV, is that they're required to enter a password with their remote control. And we all know that this is pain in the neck. And as a result of this, what happens then often is that security is sacrificed, in this case, for example, by just asking the user to authenticate once when they sort of set up the application, but then never again. And this is sort of understandable because security is something that is annoying for users. It's something that just gets into our way while we are trying to actually do other things. And I would argue that the same is to a certain degree also true for designers, because security, well, is just not the most exciting part of creating new technologies, right? And so what we often see is that we just stick with what has established itself as being just good enough. And just to stay with this example of passwords and text-based passwords. So this authentication mechanism was developed in the 60s. We're in the mainframe era, and people have at most access to one computer, right? And then during that time, it was fine to sort of type in a password like a few times per day, like when you came in the morning or after your coffee break or after the lunch break. But what is striking now is that this mechanism is still one of the most popular security mechanisms we have today, despite the fact that the way in which we interact with computers has really changed fundamentally, right? So today we can access sensitive information anytime and anywhere on personal devices, in the cloud. So the average user has 90 different online accounts, so many more than passwords than the user can remember, actually. And also we authenticate much more often, which means that there is a massive overhead in authentication time. And now I think you agree with me that this is not something that is very likely to change in the near future. And it raises the question how we can consider security early on in the design process. And from a user perspective, how we can manage to better integrate security with how we naturally interact, and optimally in a way that doesn't require us to think about security anymore. So what if, for example, our workplace, by the way in which we are using all the objects on it, and if I look around myself, I have a laptop, a mouse, a keyboard, some speakers, but also like analog things such as a coffee mug, a pen, a stapler. What if all those objects could be used to, well, understand or verify that it was actually me who is working at that desk? And so what you can see here is a prototype that we built to actually explore such concepts. So we did that like a few years back, and what it actually allows is to make literally any object that we have on the desk touch sensitive, simply using capacitive touch sensing. And this is just one technology, and we could also use cameras. But what it does is that it allows us to sort of prototype and try out new interaction and authentication concepts. And I will in the following talk a bit more about one of the underlying concepts, that is behavioral biometrics. And well, behavioral biometrics are enabled through the fact that our environment, as well as our personal devices, are increasingly being augmented with sensors. And in particular, wearables even move those sensors closer to the body. So what does behavioral biometrics actually do? Well, in comparison to physiological biometrics, where people are identified based on, well, for example, fingerprint or visual appearance, behavioral biometrics try to find unique patterns in human behavior to identify people. And so, for example, people can be distinguished based on how they walk. So by looking at features such as gait length, or walking speed, or type of walking. And in a similar manner, we can try to distinguish people based on how they write text on a smartphone, by looking at finger position, the applied pressure, typing rhythm, typing speed, and so on. And now, this basically allows us to build new authentication mechanisms that work seamlessly in the background. And in this video, and I hope you can see that well, this is just an example where I play an attacker who tries to access personal information on the smartphone of another user. Now, what the system does is that in the background, it analyzes how the current user picks up the phone, how they hold it, how they type in a search query. And then the system detects that the user seems to not be the legitimate owner or a legitimate user of the device and hence locks it. I just want to briefly mention on the side that security isn't but one application area of behavioral biometrics, but we can, for example, use it also for other things such as building adaptive user interfaces. So this is just an example from our work where the smartphone considers the user's physiology or their behavior to basically adapt the slider. But that's just sort of a side note. So how do we build such a behavioral biometrics system? So simply speaking, what we do is we observe users' behavior. More concretely, we look into specific features of human behavior and then take these features to create behavioral models of the user. And we then compare the behavior of any user of a system to these models and try to make a prediction on who is currently interacting with the system. And then, well, we can do additional things such as, for example, calculating an identification accuracy, which could serve as an indicator for the security of such a system, but I'll come back to that a bit later. Well, so this sounds as if this is sort of, well, straightforward, but actually it is not. And there is a lot of challenges, many and more of which you might think are related to human-computer interaction. And what I'd like to do in the remainder of this talk is to sort of show you some of those aspects. So let's assume now that we design a smartphone application that we want to be using behavioral biometrics as an authentication mechanism. Now, when you look at the current smartphone interface, we see that there is, well, many different user interface elements. App icons, keys, links, buttons of different sizes. And the question is now, how should we create and position elements on this user interface such that a behavioral biometric system can verify the user's identity in real time with an as high accuracy as possible? Or in other words, well, which design parameters of the user interface play an important role here? And so, in order to find it out, what we did was we looked into how different user interface elements influence identification accuracy. In addition, we also looked into the influence of hand posture. So for example, whether the user is just sort of typing with their thumb or holding it in one hand and typing with the index finger. And we also looked into the influence of the position of the element on the screen. And what we found was basically that targeting with the thumb leads to a much higher accuracy for identifying the user, apparently because our behavior is much more unique when using the thumb. The second interesting thing is that the smaller the target, the more accurate the results. And the third thing is that in particular, when interacting with the thumb, if the elements are closer to the edge of the screen, the system gets more accurate. So what one can conclude from this now is that in order to build an interface that optimally supports user identification based on behavioral biometrics, it would be good to have a user interface that uses rather compact elements, that is thumb-friendly, and where the elements are rather close to the edge of the screen. Now, what's interesting, if you look at, for example, current Android designs, is that they, to at least a certain degree, seem to fulfill these requirements quite well. There is one interesting observation here. So behavioral biometrics, or in general authentication mechanisms that reside in the background or are implicit, hold a lot of promise due to their ability to cope with the usability security trade-off. So if you think about a password, generally speaking, the longer your password is, the more secure it gets. But at the same time, this negatively influences on usability because it's more difficult to remember. It just takes longer to enter it. Now, but what is interesting here is that there seems to be a similar trade-off. Because what we found was that elements that are smaller and closer to the edge of the screen lead to a higher accuracy. But then at the same time, this means that the interface might be more cumbersome to be used. So this was something that was quite surprising. The next question is, and I get this asked quite often, is, well, how secure are such schemes based on behavioral biometrics actually? And to briefly recap, I mentioned that the biometric value can basically be used as a means to assess security. But this metric is not really based on a realistic attack model because it assumes that the attacker would try to hack the system by just showing their personal behavior. However, if I was a smart attacker and I was to break into a system that is protected with behavioral biometrics, what I would do was I would observe the victim, how this victim is behaving, and then try to imitate this behavior, making the system think that I'm the other person. And the question is this possible? And we try to find that out for a particular type of biometrics, which is keystroke dynamics, so behavior while typing on a smartphone. And what we did was we developed different visualizations that communicate to the user how they should sort of behave while typing on the smartphone. So how did this look like? We in total sort of communicated 4 different features. The first one is the size of the area of a touch, or like abstractly speaking, how hard you press. And this is visualized by the size of this red dot you see here. The second feature is the time for the keystroke, so how long the user presses, and this is visualized through the width of this gray box. Then we have the so-called touch to key offset, which is sort of the distance from the center of the key to the touch point. And we visualize that just through the position of this red dot on the key. And then finally, the flight time, which is actually the time between 2 consecutive keystrokes. And this is visualized through this white space in between 2 gray boxes. And so we showed this to users and asked them to sort of try and elicit and show exactly that behavior. And we tested then those 4 features in various combinations. And what we found out was that, well, mimicry, so we refer to this kind of attack as a mimicry attack. And we found that this is generally possible, but it really strongly depends on the nature of the feature. So if the feature is spatial, so meaning that people are required to aim precisely, so for example, the touch to key offset, then people did quite well in sort of mimicking this behavior. But as soon as they were asked to sort of attack or mimic a temporal feature, such as the time of flight, it became really difficult because people had to act under time pressure. There were more findings. So apparently when you want to modify multiple features, it gets more difficult. But yeah, people certainly became better over time. And again, so there are several implications, and just one that I want to point to here, because I thought that was interesting as well, is, so, well, the interesting thing is that spatial features have a higher biometric value, but then at the same time, they're also easier to attack. So again, you're running in sort of a trade-off here. All right, so the last aspect I want to talk about here is, well, how can we understand behavioral biometrics in the real world? And I didn't make that very explicit, but in the past 2 projects, what we did was that we invited people in the lab and sort of let them work in a very controlled environment. And the same is true for most of the work that is done in this field. And so the question here to us was, how can we collect data in a more realistic scenario? And the motivation or the assumption behind this is that behavior in the real world might be quite different from what people show in the lab. And so on one hand, we wanted to observe real contexts, and we also want to collect data from non-artificial tasks. So for example, while people are really typing instant messages or emails, rather than predefined texts that we generally use in the lab. And well, what we did was we implemented a custom keyboard app that allows us to study such natural typing behavior. And now, if you think a bit closer about this, you might sort of ask, whoa, wait, what you're doing here is you're sort of essentially building a keylogger. So how about privacy here? Because you would be able to sort of reconstruct what the user is typing actually. And so part of this contribution of this app here is that we provide a filter mechanisms to sort of cope with this issue. And so one thing this concept does is that it excludes obviously sensitive data, such as passwords. The second thing is that the user is empowered to explicitly turn off login by means of a private mode button that is integrated with the keyboard. And then the third thing is that we apply a filtering algorithm that obfuscates the logged text. And we do this by what we call n-grams, or what is called n-grams. And the idea is not to log the entire text written by the user, but just some of the touches. And so here's a specific example of what we did in the studies, how we log so-called n-grams, meaning 3 consecutive characters, which are sampled with a 10% chance. And this is sort of the text describing the Chi conference. And when you apply this filter, this is basically what you get. And I'm not claiming that it's impossible to reconstruct this text, but at least it makes it kind of, very difficult. And so we could then sort of take this keyboard app and sort of really give it to people, install it on their phone, and sort of really start collecting data in the real world. Right, so slowly coming to an end. So what I showed here is just sort of 3 examples, but the interesting thing is that there is really a lot of HCI challenges here, many more, that partly some that we are working on, some that we were thinking about. And it includes things such as thinking about how we can really integrate behavioral biometrics in everyday life, also beyond the security perspective, what the role of the user's physiology is, how we can account for changes in human behavior, and what really the user's view on mechanisms related to behavioral biometrics are. So very brief summary. So I think I have convincingly shown or demonstrated that in order to build more secure and at the same time usable interfaces, we need to really look at different stakeholders, not just end users, but also designers, developers, administrators. Then there is a need to really better understand the implications of using such mechanisms in different application areas. Today, we use them not only in workplace, but at home, in public space, in cars. And the interesting thing is that current technologies usually do not account for this. So the smartphone doesn't care whether, like which information the user accesses, whether what the user is currently doing, who is with the user, and where the user is. Closely related, going into new application areas, of course, also sort of requires us to think about how we can study and understand them. The keyboard is just one example, but there's apparently many methodological challenges. And then the last one is that really this usable security is at the intersection of many different disciplines, and there's really a need to think about how we can mutually benefit from each other. So thinking about user behavior, certainly social sciences and psychology have a lot to contribute. For data collection, I mentioned computer vision, probably. For user modeling, that's apparently sort of close to machine learning, and so on. And so just to close, if this was a really just very high level overview of challenges in this area. And if you're interested in that and want to read more, I just recently co-edited a special issue with Emanuel von Setschwitz. And in the editorial, you can find the aspects I talked about later in more detail, and you can just access it freely on my website if you're interested. All right, so with that, I'm at the end. But I don't want to close without mentioning that apparently lots of the things that I showed you here are a result of working with a lot of really great people. We don't have an actual picture because in last year apparently we haven't gotten together. But they certainly take credit for much of the things I showed here. So that is it. I'm looking forward to the discussion. Thank you very much.
Thank you, Florian, for the excellent talk. We already have some questions lined up. I'll try to group them up based on common themes because of time limitation.
Sure.
We have a question from Celine Latulipe, who asked that how diverse are your participant pools for this type of work? Do you include older adults? So this is involving overall diversity in the population pool. On the other hand, Carl Gutwin is asking about individual variability. He's asking that if techniques like typing analysis are used for continuous authentication, how much variability is there in users' normal typing behavior? Could this cause authentication error?
Mm-hmm. Okay, yeah. So yeah, just try to answer that. So yeah, this is both really excellent questions, and simply because apparently, so if you're building those models, you, depending on whether you want a person or a person independent model, you might want to sort of then, yeah, account for things such as age, and this is particularly important. Because apparently with age, your sort of abilities might change. And then the question is sort of how you account for this. And apparently, yeah, as we usually do as university, or often is that we sort of take convenience samples, even though, I mean, I really have to lie, because I would need to go back to the paper and really look into the demographics of those 30 people. I think that was certainly a much more diverse sample, because this was sort of something out of the lab where people didn't really need to come in. Yeah, so I can't really answer how the sample looked like. I would need to go back to the paper, but yeah, certainly I agree that this is an important point. Okay, the second one, can you just sort of recap what the second question was?
Yes, so the second question was about individual variability, that if the techniques like typing analysis are used for continuous authentication, how much variability is there in users' normal typing behavior? Could this cause authentication error?
Mm. Yeah, so I mean, this entire technology is built on the assumption that behavior of people differs. But then, and I think this is one of the questions I just sort of raised in the end, is how much is physiology and how much is behavior, right? And this is something that is quite difficult to separate. And that's something we are currently looking into. So we published a paper this year in Kai where we did a study in virtual reality where we changed the physiology of the user. So we sort of increased arm length or the height of the user, I think. And by doing so, what we were trying to do was to take out the physiology of the user of the behavioral model and make the model really focus on behavioral changes. And what we saw there is that this increases accuracy, which first sounded a bit counterintuitive to us, because one would argue if you have an additional feature that distinguishes people, that should make it actually more accurate. But it seems like there is really a lot of noise being introduced. And I think we have not really completely understood it, because because apparently behavior might still be closely linked to physiology. So you might behave in a certain way simply because you're, for example, taller. So you might not take this extra step because things are at your arm reach if you grab them, for example. And yeah, I think this is really something that we need to dive deeper in the future to really understand how those two things relate to each other. I hope this to a certain extent answered the question.
Thank you, Florian. There's another question which also falls under this variability topic, I think. Tawaki Takikawa asking, can this sort of interfaces be made robust to change in behavior over time, or if there's a long gap between authentications?
Mm-hmm. Yeah, that's also a really interesting question, and a very good one. So from our experience, I think models that you use to identify people have to be updated really frequently. And this might strongly depend probably on the task during which you're authenticating people. Just there's such a huge design space that we could not really deep dive into there, but apparently there is so many things that influence on how you behave, starting with you cut your finger, which certainly has an influence on your touch typing, or you exercise and have sort of muscle fatigue or things like this. And I mean, the easy answer to this would be, if you have enough data, this will be part of your model. But apparently, I guess the question is then how you sort of get to this point. And my well-educated guess would be that in the beginning, you sort of need to do a lot of sort of sampling and retraining.
Thank you, Florian. I think we can take one short question. Fabian
Sure.
asking that bit of a tangent question, but did you investigate whether there are groups who are better at imitating typing characteristics better than others? For example, piano players or surgeons come to mind.
Ah, that's an excellent question. We did not, honest answer. But I could totally see this, that some people might be better attacker than others. And I would also argue that this strongly depends on the type of behavior you're looking at. So I gave a workshop at ETRA, so the eye tracking conference yesterday on gaze-based security. And there we were actually just thinking about or discussing about, so what about if you use eye movements as a behavioral biometric? How difficult would that to be mimicked? And I would argue this is way harder as opposed to typing. So I guess the sort of the like a kind of answer is that this really strongly depends on the behavior and the task. And I could definitely see that also the ability of the attacker here might play a role. Yeah, absolutely.
Thank you, Florian. That's all the time we had, unfortunately. We really appreciate you accepting our invitation to speak.
Thank you for inviting me. It
And
was my very pleasure. Thank you.
thank you. Thank you very much.